Hi guys, it's Mike here from KS Bushcraft Down Under. Today I thought I'd have a look at and see if I can test how good high performance freezer bricks are. So, full disclosure, big fan of these Yeti ice bricks. I use these 4-pound bricks in my Yeti Roadie on a daily basis to keep my lunch and drinks cool. Super convenient, and they hold until all the ice is consumed, temperatures of about -2. So ice remains at a constant temperature until it's all used up. Okay, so it's drawing in heat from its surrounds, i.e. it's cooler, and the food in the cooler, yeah, and it'll continue to hover around 0 degrees until all the ice is gone. So that's it there. Now, back in the day when I was carrying frozen steaks and fish and stuff like that, it would never stay frozen. So the melting point of beef and fish is about -2 Celsius, so about the same point of these bricks here, these two bricks here. So they're even at that. Ice cream's about -3. Salt water, the melting point is about -2. So, and the freezing point of things that are important is beer at -2.2, milk at 0.5 degrees C, and soda at about -2. So these are right on the edge of freezing your sodas. Okay, so I've got two of these from the States. They have 3 different types. So the melting point for this one is -15. Okay, so I tested that last night. Now this became liquid when the Yeti brick was still rock solid. So they didn't both melt together, and it seemed to certainly drop the temperature lower in a pre-chilled esky. And I'm going to test 2 comparable bricks side by side. And I thought, well, how am I going to do a temperature control? Yeah, where I live today, it's 15 degrees Celsius this morning, and within about 3 hours it's going to be about 32. So I don't have 2 coolers exactly the same size or the same installation power, all of the above. So I'm going to use the same cooler, i.e. something that's a good fit. My Yeti lunchbox here. Both of these bricks are basically the same weight, and I'm going to put one of them inside here and check the temperature performance inside my refrigerator. So that's hovering around 3 or 4 degrees Celsius. So I'll set up a test bed, and we'll see quicker, colder. I honestly think that mass is more important than the phase change material in these bricks, but we'll find out. And surface area is going to be pretty much the same. So I think it'll be a pretty solid test of these bricks, whether they're like a premium fuel, but imagine volume to surface area, all this is going to be a big factor. Anyway guys, if you want to see if these things can really do what it says it does, hang in there. Okay guys, so lunch bag's been in the fridge for a while, so it should be a pretty reasonable temperature, which it is. It's about 5.9. So I'll pop our Yeti ice in. It's at -19. So I've got my temperature sender on a piece of cardboard, so it's not in direct contact with the ice. I thought that seemed a fair test. And we'll get this zipped up, and I'll get that into the fridge, and we'll start getting some data. So guys, we've just started the test. It's been in there for about 5 minutes. So the fridge inside the cooler, it's saying it's -3.1, and it's showing the fridge at 7. So we'll keep coming back. Okay guys, we're 5 hours in. The temperature is slowly starting to rise inside the lunchbox. So I think we'll have a quick look inside, and I'll hit it with the laser gun. Okay, so I've still got 1.2 on the inside. So there's a little bit of melting going on, but it's still holding around that. -1.8, -1.1, will depend where I'm firing it from. -2.9, 2.8, and we're hitting there. So as long as it continues to have some solid ice, it's holding at that sort of around -2. Okay guys, it's just before 6 AM the following day, so 20 hours into this. The pack's at -0.9, and the temperature in this before I pulled it out of the fridge was -0.5. So let's see if there's any ice left in it. The gel is cold to the touch. 0.4 on this side, -0.02. So it held the inside temperature of this case in the zone for, I'll work it out, 18 hours. Okay guys, 2 days has gone by since we did the Yeti ice. This is a lot harder to freeze. I had to position it in my deep freeze so it wasn't in contact with anything else. And I said it's taken 2 days. So we've got some good data on the Yeti ice. It did exactly what it said it would do. It held it in that sort of -0.2 Celsius range. Now this is say freezer temperatures. So the same setup as before. I'm expecting this to crash and burn really quickly. We'll let the data speak for itself. So I'll get it in the fridge, same parameters as before, and we'll see how we go. Okay, so it's 8 o'clock, so it was 2 hours in. We're at -7.8 in the... Okay guys, 11 AM, so it's 5 hours. We're going to have a look at the ice brick, just as I did with the Yeti ice. So this is now at -7, so it's varying a little bit, but I think it's following the cycling of my household fridge. It sort of gets up to about 4 degrees, then it pulls down to about 2 degrees, so it doesn't cycle all the time. I'm sure it's got something to do with the energy saving. So as I pull it out, I've got 2.9 on the fridge, so on the colder end, and -7.7. Let's shoot the brick. -11.4, -12.4, -14. A lot of melting. There was absolutely no melting at all on the Yeti ice at this point. So as I suspected, it's being consumed much quicker, but there is still some ice, and it's still doing this sort of -15°C. So we'll get it back in. Okay guys, that's 9 hours. So the inside of the lunchbox is at -0.7°C, and just by shaking it I've got it dropped to 0.9. The outside still looks positive. It's very, very liquidy. I think by shaking it I've just sort of activated it. So it's still a -14 in the middle. To -11 just by shaking it. But there's a tiny, feels like a tiny amount of ice. But it's certainly proof of concept that for 9 hours it's kept this so low. So what I'm going to do next is to repeat the test with a kilo of plain fresh water frozen into a similar shaped container. I haven't got exactly the same shape, but close enough, I think. Okay guys, a couple of days has gone past. I've frozen this little SIG lunchbox with 900 mils of water. It gives an all mass equivalent to the others. So at the moment, I just pulled out the freezer, showing -11. Same test parameters as before. So I'll zip it up, get it in the fridge, and we'll see how we go. I'm expecting a longer slow burn from the pure water. I was reading online and they're saying that salt water doesn't hold as much energy as fresh, so I'm taking that there's more cold energy, if you like, in this than the packs. But anyway, we'll let the data prove itself. Okay guys, at 5 hours into the test, it's been consistently sort of around 1 point, sort of 1.5, 1.3. So we'll have a look inside and see what we've got. Okay guys, let's have a looky inside. Can't feel any liquid. There's a slight wetness to the block. That's about it. So the Yeti ice hadn't shown any liquid stage either, but it could be melting from the inside. So there is a bit of dampness. So we know the ice is being consumed. Okay. Back together. Pop it back in the fridge. Yeah. So the Yeti we had -1.3 at 5 hours. The High Performance Tundra Ice we had -7. And this one we got +1.1 last reading. So certainly these bricks are performing as stated. Yeah, actually slightly better than I thought. Anyway, we'll get back to you with some real data. Okay guys, just gone 6 AM, so that's 25 hours in. It's still hovering around that +1.3. So I'm suspecting there's still a lot of ice left. Now I'm thinking it's the difference between the melting point of plain ice and my fridge hovering around the 3 or 4 degree mark. Okay, dokie. Well, yeah, significant melting on the bottom, but still a fair chunk left. So I weighed in 900 grams when I made the block. So I'll do a quick check on the scale. 690 grams of ice left. So guys, in summary, what do I think? Well, there is a performance advantage to these high performance ice bricks, okay? They are colder for a shorter period of time. So depending what you want to carry. So, here's an example. These are river prawns. Now for me these are hard to get, made even harder that some Burke was using prawns brought in from Thailand for eating as bait, and it got a disease out in the estuary called white spot. So these are hard to get. This packet here, a couple hundred grams probably, is for me locally about $9 a packet. If I take these out and I don't use them all, I can't refreeze them. Okay, so they just go black and mushy here. So if you're carrying a high value item, or especially, doesn't matter what higher value item it is, and you want to keep it really frozen, these Tundra ice can certainly do that for a shorter period of time than regular ice. If you want the long slow burn, water ice is probably better for giving you a long slow curve until it crashes at the end. So I think it was a useful experiment, guys. I really do. Now, I used the fridge because that gave me a steady temperature, reasonably enough. So obviously the difference between the outside temperature of your cooler, or inside your cooler, and inside a second cooler, maybe in this case, will affect performance. So the hotter it is, the shorter the burn time is going to be for these as they discharge at that set rate. Anyway guys, if this content helps you out and helps you make good decisions and stuff, don't forget to like and subscribe, and I shall see you next time.